Okay, part two of the RPLidar based 3D area scanner. In the last video I just was finishing up just doing a test on the Z-axis rotation, and then, of course it didn't move because it's on camera. But looking at the program, last time I was screwing around with the frequency of the stepper driver and I had forgot to put it back, so now it's back where it needs to be, and I'll give that test run a go again. And it's like I was talking about in the last video, the stepper motor driver, the TMZ 2209, has some onboard tuning that it likes to do, so it's good to run it a little bit before you actually get to scanning. So it's just bouncing 180 degrees clockwise and counterclockwise. The normal scan direction is clockwise. Despite the chaos of wiring right now, it's ready to scan. And so I'll open up the scan file, and I'm going to go up to the parameters real quick. And what I plan on doing is maybe just doing a quick scan. So right now it's set at 6,000 for the Z index, so that means the 6,000 times it's going to take a scan. So I'm just going to make that 1,000. So it's a pretty coarse scan at that. And the number of times it scans in each position is just make that one, so maybe a maximum of about 4,000 counts per scan point. Below that I have a distance limit set to be 4.5 meters, so anything beyond that I'll throw away. Let me get this started. Okay, once in a while the RPLidar module has a communication error, and so to get it kind of reset, there's another utility I have that just run it a couple times and then it'll bring back up the. So right now it's connected, and we'll be able to. Usually you get that when you terminate the program early without cycling the power. So those are all good things right there. And right now we've started scanning. And so the original scanner didn't have a sensor on it, so it would actually time out how far it would have to rotate for each Z-axis position. And so it's still doing that, but instead of using the calculated position, it's actually using the measured position to gather data and then store it on an SD card. And just for reference, it creates the files over here, and some can be quite large. Like for instance, that one's a smaller one at 294 kilobytes or megabytes, excuse me. And one of the things about the RPLidar module is that I had this thing set up to scan 180 degrees, and of course the RPLidar module is scanning 360 degrees around on the vertical axis, on a vertical plane, on that vertical axis. So you should only have to rotate it 180 degrees and you would get full spherical coverage of the entire area. But I had a lot of issues with kind of a leading edge, trailing edge sort of thing with the RPLidar module, where it's if you scan in one direction, say the laser point is a point, then it's actually not the case, but it's actually something that grows maybe out to be the size of a quarter at some distance, and it shrinks down. And so when I would scan 180 degrees, kind of like the scan point would be the lead edge on the front side, and it'd be the tail edge on the back side, so there'd be like that parallax in the scan data. And so to overcome that, I've actually telling the program to only scan 180 degrees in front of the scanner and then rotate 360 degrees. And so that's what it's doing, and because it's actually scanning the backside as well, I'm collecting those two sets of data as different files. And it's kind of neat to overlay them. You can kind of see the twistiness or the error in the RPLidar module about how it scans. So it's like there are two universes, maybe Bizarro universe and normal universe, and you put them on top of each other. There's enough difference between the two that each by themselves looks perfectly fine, but and you can take measurements and get pretty decent numbers. But when you try to register those two scans together, they won't register because of that parallax error. Probably using the wrong words for that. But as I've been speaking here, it's been scanning pretty nicely. We've already scanned about 120 degrees of rotation. Once it gets to 360, it'll stop. And then we'll have our scan data. I think the last few minutes of video kind of show some more things on the screen with. And so there's a couple of programs to use. One is the Cloud9 software that's actually embedded in the BeagleBone Green. And since I've grown accustomed to this, it's pretty decent. However, it'll allow you to download files directly from that to your hard drive, but these files are large enough where it doesn't have the ability to do that. So in order to transfer files, I use this utility, WinSCP, and it's pretty decent for grabbing files off of the 3D scanner and then bringing them down to your hard drive or wherever. So connect up with that. And there we go. We have a few point files. Looks like one's under construction yet. It's going to not actually be that large. Okay, and then actually for cloud software, there's this Cloud Compare, which is a free software I found on the internet. And I think it's pretty nice for just kind of looking things over, and you can merge different clouds into a single mesh or point cloud, sorry, separate ones, or do some work to basically register them by eye or by hand. So there's two scans, kind of bring them over the top of each other and do your best to line them up, use utilities on there, and go from there. And you have the ability to kind of look at your points and zoom in and zoom out. Actually, the software I like using the most for point cloud type data is this scene software, which is from Faro, which is the scanner that I've used professionally, I guess. And what I've built is not even close to what those things are capable of doing, but I still like using their software. So up here on the right, I have a couple older scan files from a while ago, and you kind of see the A and the B. That's the, what I talked about before, scanning two separate point clouds at the same time. I'm just going to open up the data on one. Maybe bring that into alignment here. I'm not sure actually what the scan is, but okay, it looks like I was playing with this and I modified it a little bit. It looks like a scan on my desk a little, with just some of the other features cut away and tossed out. So one of the things there's a lot of things that Scene can do. You can take measurements, convert these points to a mesh, put an ortho view, and sometimes it's a little easier to see. So if I were to just do a quick measurement, say of the drawer, looks like it missed the point there. That's right. We'll just go from the top of the, or bottom of the top to the top of the top there and see what we get. Okay. That one doesn't seem to be working. Sometimes scene, that's not a point cloud issue, that's a scene issue. And hopefully they get that corrected at some point, but let's try a different file and do the same thing. That looks like my office chair. So I kind of stop and let it catch up. So I'm kind of looking back towards the corner of my office, and the bookshelf behind me, things along the wall, and kind of get in there and see the American flag. And let's maybe end the video there. Scan's almost done, but I think I've gotten close to the 10-minute limit here for my account on Google.